Right, question 17. Four wooden struts are used to support a platform which carries a load of 20,000 newtons. The timber has an ultimate tensile strength of 21 meganewtons per metre squared on average when tested. Calculate the cross section of the square timber that should be used as a minimum if a factor of safety of 6 is to be used. Right, the load equals 20 and 10 to the 3 newtons. The factor of safety there is 6. FOS, factor of safety equals 6. And the ultimate tensile strength, UTS, is 21 by 10 to the 6 newtons per metre squared. And calculate the cross-sectional area. Right, well, first of all, the UTS equals the max load divided by the original area. Right, so, and also another formula here, the safe working stress, or the safe stress, is going to be equal to the ultimate tensile strength divided by the factor of safety. So we have the ultimate tensile strength, that's 21 by 10 to the 6 divided by the factor of safety, which is 6. So the safe working stress is going to be 21 by 10 to the 6 divided by 6. Change that and we get 3.5 by 10 to the 6. 3.5 by 10 to the 6, and that's newtons per metre squared. Right. So I think we might be using this equation next. Now, you see, with 4 wooden struts, 4 wooden struts. So each strut, the load on each strut is going to be 20 kilonewtons divided by 4. And that gives us 5 kilonewtons of load. That's 5 kilonewtons per leg, load per leg. Alright, and per strut. Also sigma stress equals force divided by area, and therefore area equals force divided by sigma. Right. So the force, the load on each leg is going to be 5,000 newtons, and the sigma, the safe working stress, we've worked that out already, that's to be 3.5 by 10 to the 6. So divide 5,000 by 3.5 by 10 to the 6, and we end up with 1.428 by 10 to the minus 3, right? And this is the area per leg, the cross-sectional area per leg. So remember, it's a square timber. So if you think about it like this, square timber, look at the side cut of it, x times x, so the side x squared is going to equal 1.428 by 10 to the minus 3 meters squared. So we get the square root to get the length of one side of that square. X is equal to the square root of 1.428 by 10 to the minus 3, and that works out to be, we'll do it here, 1.428, and we 10 to the minus 3, we get the square root of that, and we end up with this figure here. Change that, and you get 37.78 by 10 to the minus 3, which is very similar to the answer there. Round to one decimal place, 37.8. 37.8 by 10 to the minus 3 meters. Right? This is the length of each side of the square section of leg. And that's it. So we didn't really use this equation here, I suppose. Sigma equals F over A equals F over sigma, etc.